Hello everyone, my name is Gilbert Andanje and you're welcome to my YouTube channel. Today we are going to revisit recursion and memoization, and in particularly the bizarre behavior in Python and JavaScript. Now, if you're new to programming, this could be a mouthful, but if you're watching this in future, I'll be sure to leave a link in the description below to these foundational concepts. Now, recursive functions are essential in our day-to-day needs. Where iterative implementation of a function does not apply, you are likely to use a recursive approach. Now, the downside is recursive functions tend to take a lot of memory on the call stack. That is where memoization comes in. However, you need to be careful while using memoization, especially in Python, because of the way Python itself is written, or how Python handles these immutable objects. So in this tutorial today, we are going to use CANSUM and HOWSUM functions for illustration. And again, if you're not familiar with CANSUM and HOWSUM functions, I will be sure to leave a link in the description below in future so that you can come back and learn HOWSUM and CANSUM functions. But if you really want to know what they do right away, you might want to look online and then come back and catch up with us. However, I'll go straight to today's tutorial. And then here with us we have CANSUM function. Usually you're given a target sum and a number of arrays, and you're asked to find if it is or not possible to achieve the target sum using the numbers given in the array. Now here is a call to this function with 7 as our target sum in the first function, and then the array is 2 and 3. Now given this array, it's possible to get 7 by just summing 2 and 3. So this combination here, they exist in our array and they will add up to 7. Now this should return true. And then in this other function here, we have 5, 3, 4, and 7, and our target sum is 7, and it should automatically be true because we already even have 7 itself in the array. Otherwise, we also have 3 and 4, which add up to 7. And then on the third function, we are calling we are passing 2 and 4 as the array argument, and then 7 as the target sum. Now for these is false because none of these can really add up to 7. There's no possible combination of 2 and 4 that can give you 7. And 7 and 14, it will end up to false. However, this is solved recursively. This will take a very long time, and that is why we will introduce memoization. So if you want to see how this will take time to solve, you can do it on your own without just passing the memo object. In fact, I will do it right away so that you can just see. So first of all, let me just remove this memo object here so that you can see how it will take time to solve that. And then I will comment out this line, and then we don't need to pass the memo object here. And then again, I'll comment out this and comment out this part, and then we are good to run our function, so that you just see how this will take, that why we needed memoization here. I'll go straight ahead and debug that. So just to show you how expensive it is to run this, I'll go ahead and just remove this memo object inside here. Okay, and then I'll also comment this line and comment take out this memo object again from here and comment this line, comment that line as well as this. Now we are ready to run our code so that we see how expensive it is to run a recursive function on the call stack without memoization. So you can see it's running. We've already gotten our first 2 answers, which are true, true, false. We expected that. The last one is gonna evaluate to false, but you don't want to keep running this because it's just going to make this video unnecessarily long. So instead, I'll just go back to our memorized function, and then what I will do is I will run this so that you now see the importance of memoization. I know you already know, but so let's just run this so that you see how fast it's gonna evaluate. And there we go, and we already have it: true, true, false, false. So this is where memoization comes in handy. We all know this, but you just need to be careful while doing this in other languages, like in Python. So this is basically the Python implementation, and you can see here the same functions and the same actually the same function arguments, and we expect our true, true, false, false evaluations. But now when we run this code, just see what happens here. So Python will run, and yeah, look, we're getting a true, 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 and false. So it evaluates this fourth function called to true, which is very weird, right? Because we both know that 2 and 4, there is no possible combination of 2 and 4 that will evaluate to 7, right? So in that case, we have to dive deep and just see what is really happening under the hood, and we can do that by trying to find out, since we had 332 since we had 223 evaluate to 7, like sum up to 7, we want to see what possible combination is this of 2 and 4 that can give us 7 and return true, because our code should be right? So we'll start with JavaScript, the one giving us the right combinations. So I'll clear the screen, okay? So, or maybe I'll leave the screen for now, and then I'll just go to the debug console and debug that, and let's see what we get. So right here we are getting the first one, and remember this is still memoized, okay? So the first one is giving us 322 as we said before, and then the second one we are taking a 3 and 4, and alternatively you can have a 7, and the last one it's evaluating to null null. So this one is very true because they didn't find any possible combinations to add up to 7, and with 7 and 14 there's no possible combination of getting to 300 as the total. So this is true. This is what JavaScript is giving us, so it is our benchmark as we move to Python. Let's see what Python is giving us, right? So for Python, initially we found that it evaluates to true, true, false. So we want to see if this at all this is true, then what is this possible combination that is evaluating to 7? So we are going to run the same code, and we are not going to delete that. We are not going to clear our terminal so that you just see what is really happening under the hood, right? So you see Python, okay, Python should give us, now here it is, these are values from Python. Python is throwing a 322, which, yeah, it's possible to get generate 322 or rather 7 from that 322 from the same array, because it just took 3 and it took 2 twice, and then it got 7. Now coming here to the next function, it's giving us the same 322 and a 5. So it picked 5 from here, but then it's really returning the same 322 in the first function call. And that's weird because you see in this function call, every function call, we are passing a default object that is empty, okay? But then we see that the 322 is carried. The state of 322 in this is carried forward to the next function, and this is the problem with Python. So when you create a mutable object in Python, it's a global object, okay? So that every function globally can access the same mutable object. So you realize on the second function call, this function tried to modify, it just tried to modify the memo object that we created in our first function call, and that's why the 322 is still there. And so when it hit the 322, it returned true, okay? And at the same time it returned true here, and that is why we are receiving a true for this function, even though there are no possible combination. It thinks that it basically went and found 322 in our memo, and that evaluated to 7, and that is how we got a true value here, boolean here, which if you didn't really debug, go deeper and see what your function, your returns, then you will likely get a wrong answer and be beating yourself up like what's happening. So just to see what is really happening here, it is because now, okay, now to avoid this misbehavior of mutable functions while you're doing your memoization in Python, all you need to do is make sure that all these functions are accessing a unique memo object. Or so you can do that by creating pointing every function call to its own memo object that is different from the next function call, so that you avoid modifying of mutable objects. And there we have our first solution. We created a memo for the first function call that we have passed into our default argument here, and then the second one we also pass into the second. So when we run this, you realize that we are going to get the right answers that we are looking for, because now yeah, there we go. So because we're going to get the correct answers because now we are referring to a fresh memo objects with every new function. So this is what you expected to get in your in your runtime. And had you not added this, then you see your Python would throw something very strange to the screen and leave you wondering. So now the best way you can optimize this function by just setting this memo object to none, like here, right? So this one solves the problem, and in a very clean way, and this makes your code very reusable and very reader friendly, and you're also using up less memory. So that is it for today's tutorial. Now if you have any more questions, kindly let me know in the comments below, and if you like the video, hit the thumbs up and subscribe to my channel if you're not ready yet. And we love you all. Bye.